Let's get this fired up. Here we go. So with a transmitter, there are two main ways of using it. Okay, two main ways. We can break them down further, but the two main ways are connection and induction. Connection is, as it says, it's when we're hooking it up to something, typically using our direct connection leads or a signal clamp or a plug-in adapter. But connection is when we're putting something in the port of the Genny. Okay, we're sticking something in. Induction is when we just use the box on its own, and that's where you may have seen it being used, where we just sit the box on top of something. Okay, we can break that down further into these four little scenarios: connection, clamp, plug connector, and induction. Okay, they're the main ways that we use it. One of the things that we teach people, guys, is that we always start with the Genny. Okay, so obviously you're going to check your plans, you're going to do your visual check and everything else, but in terms of operating modes, start with the Genny first and let's go for known services. One of the terms that I sometimes get frustrated with is this talk all the time about cable avoidance, and I think we need to be talking more about cable location. We can't avoid something until we've located it, and that's the mindset I think we should have on site. Is we're not just going to do a passive scan and see if there's a signal there. We're going to actively go out and look for these cables and find them. So with the direct connection at the top, guys, just to explain how this works for anybody that's new to it. In fact, on that subject, let me just check this poll just to see experience. Yeah, 84% trained, 15% not. Okay. So if we look at the picture on the top left-hand side, we have our transmitter here, our Genny, and we've hooked up to this valve on this metal pipe. We've placed an earth in the ground, and in very simple terms, what's happening is we're creating an electrical circuit, which then gives off a magnetic field that we can detect, and it's kind of doing this. So it's coming down here, and then it's returning through here. Okay, I'm going to keep my drawings very simple today, but what you do need to understand a little bit is that when I draw these pictures and diagrams out, we talk about the signal going in one direction. The truth is it's an AC signal, so it's actually going in both directions. It's going backwards and forwards. Okay, but just for easy diagrams and explanations, we draw it going one way. But as I said, it's kind of going, backwards and forwards on that. Okay, so that's how we typically use direct connection. We've then got the signal clamp, which is what we put to put it around an exposed cable, maybe an exposed cable in a trial hole or in a chamber, that kind of stuff. Plug connected down here to go in a domestic socket. Don't use that as often as people used to, and then we've got the induction method. Okay, guys, bit of feedback. Is it all making sense so far? Everyone following me? I always worry when the chat goes quiet. One of the biggest problems with doing webinars is I can't see your faces. So I don't know whether you're looking confused, interested, or asleep. So I'll just jump in now and again and ask you for a bit of feedback. I've just got somebody that can't get in the room, guys. Just give me 1 second. Let me see if I can get them in, because it is the last one of these today. So I don't want to make sure if somebody wants to get in, we can jump on it. I'm just going to send somebody a direct link to jump straight in. Sorry. Great stuff, guys. Right, so let's move on then. So the first method we're going to use is connection, and this is where we're going to start talking a bit about the methodology that we're going to do. I'm a great believer in doing street lighting first. I think it's good that we should get people into the habit, if you like, of working through a methodical process when we're trying to find buried utilities. I think it's a really good habit to get into, that we start with the street lighting. And there is a reason behind that, and it's about time. So let me just expand on a couple of things, guys. We're going to use our Genny to trace the street lighting. And remember, guys, this is UK based. If you're tuning in from overseas, just bear that in mind. We're talking about UK networks, but there will be similarities. The street lighting works in one of two ways in the UK typically. It's a teed off system, or it's a loop in, loop out system, as you can see on the diagram there. So teed system at the bottom, first of all that simply means is that the same LV main cable in the street that feeds the houses, we have branches coming off to each of the properties, it also feeds the lighting as well. So it's teed off the LV main to feed the lighting columns. Okay, and the top one is what we call a loop in, loop out system, and this is typically where we have a dedicated street light cable that kind of comes in and out like this. Okay, they're the two systems. Sometimes you don't know till you get to site which one it is. Sometimes the plans will give you a clue, not always. Sometimes you just don't know till you get there and start locating stuff. All right, so let me just go back to that same point of why are we doing it first. Imagine this is just a very basic, typical street scene. We arrive at this site and we've got an excavation to do, and the thought process should be, we know we've got a main LV, we know we've got 3 house services, we know we've got lighting cables, we need to find them. As I said before, guys, what we don't do is just start, doing power and radio scans. We're going to go and actively find these. So with that in mind, what I want to do now is locate all these cables with my transmitter. And what I could do is hook my Genny up to each of these buildings to apply a signal down to these in turn. So I'm doing, 1, 2, 3, that locates this. And that could take me about 20 minutes to do that. After I've done that, I then hook up to my lighting column. And what I suddenly realize now is that because it's a T'd system, the signal goes down here, it goes up here, and they even pick up these. So what have I just done there, guys? Just wasted 20 minutes. If I'd done the lighting column in the first place, I'd have found all that. So I'm just trying to save a little bit of time. Now, guys, I want to be clear. Even if it's a T'd system, you might not find all that, okay? Sometimes you'll clip on that column, you'll only find the lighting. Sometimes you'll clip on the column, you'll get the tail and the LV, and you won't pick up the house services. But my point is, let's first of all see what we can detect off that column, and it might just make life a bit easier for us, might save us a little bit of time. Does that make sense to everyone, guys? Okay, are you with me on that? And that's why we typically do lighting first. Okay, right, so we've talked about our first step. Let's now look at it in a bit of detail now of how we actually do it, guys. So this is us hooking up to our lamp column here. So for anyone that doesn't know, guys, very straightforwardly, we get the transmitter, we hook it on, and we earth it. One of the things that I've not got time to go into in a great deal of detail on these sessions is the new Genny4 series now. They actually send out 2 frequencies. Okay, so that Genny is kicking out 33 kilohertz and 131 kilohertz simultaneously. And when you put your cat on Genny mode, the best way to describe it is when you've got it turned up quite high, you'll often hear both frequencies. And then when you turn it down, you hear whichever one's coming through the best. If you guys have been using Cat4 on Genny mode, you might have noticed that sometimes you hear different noises, different tones. And it's all to do with these simultaneous dual frequencies. What the 131 kilohertz allows us to do is, because it's high frequency, it jumps gaps. So some of you might have seen little tricks where you can wrap it around the pole and things like that. If anybody's seen that before, have you seen that before, guys? Wrapping it around. So it's quite a new technique, this, and the industry kind of went a bit mad with it. But I will say that on a metal column, it's better to connect. Okay. All right. Is anyone else's screen frozen? Rachel, if you can hear me and your screen's frozen, try reconnecting. Is everybody else still there? Okay, so just to summarize, guys, yes, wrapping it around works, but if you have got a metal column, connect on. I tend to use wraparound techniques more for like concrete columns and stuff like that, and even then sometimes you might struggle. Okay, so that's how we actually hook up to a column. We're hooked up here and we've got our pin in. Now, I want to ask you a question, guys. It's always very interesting asking this question on training courses. Where do you put the earth? So we've hooked up to the column. Where do we put this? How far away does it go? What angle does it go at? Does it actually matter? Do we just stick it in the ground? Give me some thoughts on the earth, guys. And I said the reason it's interesting is when I ask this question, I get loads of different answers. There doesn't seem to be any consistency on where this goes. What's your thoughts on it? So what I want to, just while you're answering that, guys, what I want to talk to you about actually is there kind of is no correct position as such, but what I think we're missing a lot out there is understanding of what effect it has. Okay, it does different things depending on where you put it, and we need to take these into consideration when we're hooking up. Yeah, I think you're cheating, David. I'm sure you've been on the course with me before. Let's look at a few examples. See if we've got any more answers coming in. Further away, mixture of stuff there coming through, guys. Okay, let me just show you a couple of things then, guys. So, by the way, guys, my drawing's a bit crap, so just bear with me while I draw you some of these diagrams out. If we look at a lighting column, so this is a plan view looking from above, and imagine looking down and we've got our lighting column here. If we get our Genny and we hook up and we put it quite far away, let's say 2 or 3 meters away, so this is the earth wire now. I'm pretty sure that you would all agree, wouldn't you, that this earth wire is giving off a massive signal. Yeah, agree with that? So in other words, what this means in the real world is that I can't go here with my locator. If I go in that area with my locator, I'm going to pick up the earth wire, not the cable. If the lighting cable happens to be in that area, I'm not going to be able to pick it up properly. So what this means in turn is I have to move further away from the column. So instead of doing that, consider this. That's our lighting column. We get the Genny, we hook up, and we put the earth really close. Everything's tight to the column now. Everything's really, really close. And I can now do a nice tight circle around that with my locator. And it doesn't matter which way that cable goes, I can still locate it. People often ask me, how close to a column can you work to, guys? It's more about where's your earth? Yeah, have you got that stretched out miles away and it's interfering with what you're doing? So put it nice and close on a column. Okay, that makes sense, guys? Happy with that? There are reasons for moving it further away, and we will cover them later, guys. But for now, just consider that. And the other thing I want to touch on, guys, is we're still using like old habits from years ago. If anyone remembers the old handbag Gennys, the older Gennys, you did have to move it right out at 90 degrees to get a signal. But you don't. These modern Gennys are fantastic. Genny4 is a cracking Genny. Okay, you don't need to do it with these now. You'll get buckets of signal down that lighting cable just by putting it close like that. Okay, you don't have to go far away, and then you can work really tight in then as well with that lighting column. Okay, so hopefully you're okay with that. The other thing that I want to start discussing with you now, and we do go off on tangents here, guys, because we need to look at each step of this, but we're going to talk about how far a Genny signal will travel. So again, I'll throw that question to you guys. How far will the Genny signal go? Now, you guys using high-end kit, frequency difference will affect that, but think about single frequency now. Think about only having one frequency to choose from. What else would affect how far your Genny signal travels down something? Just one more point while you answer that question, guys. If you can't get the pin in the ground, if you're on tarmac or concrete, you can earth it with some water. So this example here, just stick the pin on the floor and pour some water on it. It doesn't have to be sparkling water. Any liquid will do. I'll let you use your imagination on what type of liquids have been used in the past. Okay, so let's start again. So we're still on that same question, guys. The answers haven't come through yet. The problem, we've got so many on it today. The delay's a little bit worse, I think. But anyway, I'm gonna move on. Before we start answering that question of how far that Genny signal will travel, we need to start understanding a few more basic elements first about what that signal's doing and where it's going and why. So I want to give you a few examples here, guys. We've hooked up to this column now, and we've put our earth in. Okay. We're going to keep this very, very basic now, guys. So these figures will not be exactly scientifically correct. It's just an easy way of understanding it. But if we look at the signal on this cable, let's say we have 100%, just for easy maths. Okay. And what I mean by that is, if we had two cables coming out of the lamp column, 50-50. Okay. So hopefully you're with me on that. All right. So this 100% now is going to come down here. It's going to hit this. Okay, and what's it going to do here, guys? So 100% has hit this. What's going to happen now? I know there's a few pauses because of the questions, but I think it's important we keep this interactive, as I said. So just deal with the delay a little bit. What's going to happen down here? Okay, the signal's going to split, isn't it? Okay, it's going to go both ways along that cable. What we have to now consider, though, is how much will it split? Will it go 50-50? Okay. And all this now depends on what we call the path of least resistance, basically. So somebody said 50-50. Okay, that signal is trying to get back to the Earth. Okay, so no, let's just backtrack. We're still talking about how far a Genny signal will travel. Okay, let's just backtrack a little bit now and look at the difference between tracing a pipe and tracing a cable. You might be able to relate to this in the real world, guys. When you put signal onto that cable, it is an insulated cable. So effectively what that signal is trying to do, remember this, guys, that signal is trying to get from A to B. That's the best way to understand it, all right? So that signal is coming down this insulated cable. The cable's insulated, remember. So it needs to get off the cable. It needs a contact with ground to get off. So what it's actually looking for is an earth. Yeah, exact, spot on, yeah. So just imagine this. It's going to come down here, up into there. That electric cable is bonded to the metal pipes underneath and comes down and it comes back. Does that make sense, guys, again? All right, so it's kind of got to run down it, you know, to the next lamp column or a point in the ground. Now, consider this. What if that was a metal pipe? What is the difference? Well, a metal pipe, most metal pipes anyway, not all, are in contact with ground, aren't they? There's no insulation on them. So if that was a metal pipe, that signal is going to travel along it, but all the time it can leak off and come back. So to translate that to real world tracing, what you tend to find is that when you're tracing a pipe, as you walk along the pipe, the signal's dying off very rapidly. You've got to keep compensating for that by turning your sensitivity control up. When you're tracing a cable, you tend to find it's much more constant. One of the things that come up as well was from Joe, the conditioning of the LV main. Absolutely. Yeah, you sometimes find with these old mains where the insulation's a bit corroded and stuff, it leaks off much quicker. Yeah, it's a bit more like a pipe. Does that make sense, Joe? I think that's what you're referring to on that. Okay. Yeah, and sometimes it's not just a case of jumping, Zach. It's just coming back down something else. So think about return paths. Yeah, that signal's getting back to here. If there's something else going this way that's a conductor, it will travel down that as a path of least resistance. Yeah, so that's why we can get signals kind of jumping, if you like, you know. And also, don't forget, guys, what it can also do here. Let me show you this. Yeah, think about this one. So that signal is going to come down here, up here, into that house, down on the metal pipe, back out on the metal pipe, and down the metal pipe. Yeah, that can happen. Does happen. Generally it's much weaker though. Yeah, and especially because the pipe's deeper as well, typically. Okay. All right. Also, back to what I said about pipes, guys. Bigger pipe, the harder it is to get distance down it. Can you see that? Because you've got more surface area in contact with ground, so it leaks off quicker. So have you experienced that before, guys? Have you ever noticed the difference between tracing a pipe, tracing a cable, and it's down to the insulation? And if anybody's ever traced a high pressure gas pipe, trace it for a considerable distance. So that kind of is contradicts my argument, yeah. But there's a difference because a high pressure gas pipe is insulated. It's coated, you see. So we go further on. Okay. Is everyone with me so far, guys? Yeah. Let me know I'm making sense and I'll move on. So we've talked about pipes and cables, yeah? Now let's go back to our signal splitting now. Talk about that a little bit. So if you remember what we had this signal coming down here. Now remember, this is back on this insulated cable now, isn't it? Yeah. It gets to here. What's it going to do? It's going to split, but as we said, might not be 50-50. It's going to go where the better earth is. So let's say, for example, we have a substation down here. Substation's got a massive earth mat underneath it. Which way is it want to go? Which way is it going to want to go? It's going to want to go left. So what we might find here is we've got 70-30. I don't want to overcomplicate it, but I'm just trying to be clear not to expect 50-50. There's just outside our office here, there's a substation near some terraced houses. You hook your Genny up to those terraced houses and all of your signal, 100% of that signal goes towards a sub. Very, very hard to get signal to go back up the other way. Okay. Okay, so we're going to use 50-50 as an example, guys. And the other thing on this, guys, it's always a fine line with these sessions. I'm trying to share with you as much as I can, but not make it too technical and boring. It's very important, I think, that the guys on the ground understand this, because if I follow this up here, let me just kind of show you. If I follow this up here, and it takes me round here, yeah, that's my trace line, if you like. But when I get to this point here, can you see where I'm drawing the X? When I kind of get around this corner, I notice that my signal has dropped. I've lost signal. What does that tell me? It tells me that even though the big signal, if you like, is taking me round to the left, even though that's the route I followed, because I've lost a little bit of signal there, where's that signal gone? And that then sets alarm bells off. Actually, is it a bend or is it a T-junction? Do you see what I mean? Has it come off somewhere? And that's why I'm a massive fan of manual gain and manual sensitivity and stuff. I think we can see a lot more when we're using that. So anyway, oops, sorry. Let me go back to this. I will get there in a minute, guys, with this signal splitting. We will get back to that. So we've got down here, and guys, we're going to use 50-50 as an example. So 50's gone that way and 50's gone that way. So that 50 is going to go up here, and then what's it going to do here, guys? Yeah, same thing again. It's going to split, but this is what again you need to consider. How much signal will that property take? What does it depend on? It depends on the earth. Modern houses in the UK with plastic pipes, you typically use a PME system. Again, I've not got time to tell you all about it, guys, but essentially it means that modern houses in the UK that have plastic pipes, so even though I say modern, it could be 10 years old, they do not have a physical ground at the house. If there is no physical ground at that house, it will take hardly any signal, possibly even none. If it's an old house with metal pipes underneath it, those metal pipes under your house act as an earth. It will take some of your signal. So let's just keep it simple, guys. We'll pretend these are old houses. I've got 50 here. That's taken, let's say, 25. I've got 25 left. That's taken half of that again. I've got 12 and a half left. So let's go back to the original question that prompted this. How far will the Genny signal go? Can you see what's happening? As I go up here, guys, every house is taking away half my signal. I'm not going to trace very far up that LV main, am I? So can you see that the more branches that come off that take signal away, the less distance you can trace? So imagine the difference between a terrace street with houses very close together and a big posh street where there's massive mansions. Can you see the difference that you'll have there? Also, guys, think about this. If these were modern houses that didn't have an earth, how much signal would they have taken? Very, very little. So you'd have much more signal here and you could potentially trace further. Okay. These are all factors we need to think about when we're trying to get the best out of this Genny when we're out there, guys. Any questions on that, guys? Hopefully it all makes sense, I hope. Let's look at a couple of real examples and some things we need to consider. What I find quite a lot is that we're getting people to use the transmitter more. But the next step, if you like, I think, is getting them to understand it a little bit more and to use it in different ways. I think a lot of people are just doing stuff like off the lamp column, for instance. I see that quite a lot. And I'm going to show you some problems with that. Again, talking about, signal strength and stuff. Let's just look at a typical house scenario. Brian's saying he's froze. Yeah. Okay, everyone else is all right. Checks sensitive. So let's just look at a very typical example, guys. I've got a house, I've got an LV main and an LV service, and I've got a lighting column here. Okay. If I connect my Genny onto here, think about what we talked about before, guys. We got 100% on this, 50. The house takes 10, and I've got 40 left. Hopefully that makes sense. So to visualize this, what we're trying to say here is that the Genny signal on the LV main is big, and the Genny signal on the host service is small. What that usually means is that I can find the host service here, but then when I start to follow it down here, okay, I can't quite get it accurately where it meets the main. Yeah. Now, this is where we have to consider what are we doing in this street. So thinking about somebody that's digging a hole and excavating, if they're excavating over here, I would personally argue that that's enough. And what I mean by that is they know where the house service is and they know that it's not near their excavation. So the point where it exactly meets that main is a bit irrelevant, really. So I would say that that's fine. That's enough. Yeah, we're happy that we found the house service. It's not what we're digging. However, what if we was digging here? If we had to dig near that house service, I would now argue that that's not enough. That level of accuracy to me isn't good enough. So what we do instead, I shouldn't have deleted the whole lot, but I did. That's our house again, same thing. So if this, oh, sorry, something's foul. We're back, yeah. So if we click on the house instead of the column, can you see what's going to happen now? We've got 100% on here, and then we've got the weaker signal, the 50-50, if we call it 50-50 on the other main. So now it becomes easier to trace this to here. Okay. Another example quickly, and I want to show you how important this is. I've got a little example of this in relation to cable strikes that have happened in the past. Imagine this scenario. We have a house. This is the garden wall, if you like. So this bit here is like the driveway. Okay. Then we have the LV main with the service coming out of the house, then running parallel and then back onto it. That's not uncommon, that, guys. Does that picture make sense, guys? First of all, just chuck me a yes in there. Okay. Doesn't look right to me, but hopefully you get the idea. This is the cable. Yeah. Lamp column here. So clip on the column. 100% on this, 50, that takes 10, and I've got 40 here. Okay, now we scan across here and we find that cable on the driveway, no problem. We then follow it down, but then when we get to here, what do you think happens now? We end up on here. As far as we're concerned, that meets the main here, because we can't see that 10 when it's next to the 40 because it's so close. We can see the 10 up here, because there's nothing bigger that's right next to it, if that makes sense, guys. But when we put that 10 next to the 40, it becomes very difficult to see the 10, not impossible. So typically, that's the kind of cables that get hit. However, if we apply the signal to the property, the signal on this one now is 100. You see that? The signal on this one is 50. We've completely reversed the situation. The big signal now is on the service, not on the main, and it makes it easier. Even when you've got them coming across and looping back on, it's much easier to work off that building. So if you are out on site with the guys and you're in charge of teams, just try and encourage them to think about where they're actually applying that Genny signal. Okay. The Genny's great, it's fantastic, but we have to understand that it's not magic. There's still limitations with it that we need to understand. Any questions on that, guys? Again, I hope everyone's all right with that. It's so difficult not seeing your faces, but I hope everyone understands that. The other thing that's also important as well, and I come across this quite a lot, going back to this one we talked about. Do you remember we talked about how each of these joints were losing half the signal? And this is why we do not teach zigzag scans. Zigzag scans are outdated, in my opinion. We shouldn't be doing it anymore. What we should be teaching people to do is to find that cable or the pipe or whatever and trace it and follow it and notice signal change. Because if you're walking up here with your locator and your signal suddenly drops, what does that tell us? We've lost half our signal. Why have we lost it? There's a branch. I see this with a lot of the guys on site. They'll be tracing the cable along. They suddenly lose half the signal. And they just turn it back up and carry on. There's no thought process there as to why that has happened, if that makes sense, guys. Okay. Yeah, Jake, exactly. I mean, we're just talking actually locating it with a cat. My job is to teach you to be able to get the best out of locators, but yeah, definitely trial holes in that, of course. So. Any questions, guys, so far? Feel free to chuck them in. in the box if you've got anything you want to ask or anything you want to expand on. Let's go back to the earth position. Okay, we talked about you know, putting it near a lamp column, but do you remember what we said with a cable, with a lighting column? Because it's insulated, it's kind of got to run down it, hasn't it? It's got to flow down it. So, but remember we said about pipes? Pipes are not insulated, so we need to consider a few things. If this is our metal gas pipe, this is looking from above, plan view, or a metal water pipe. If we hook the Genny up and put the earth quite close here, what we're effectively doing there is we're encouraging the signal to jump off. Remember, with a cable, it's more difficult because of the insulation, but with the pipe, we can lose a lot of signal here. So when you talk about moving the earth further away, if I put the earth further away, I'd basically trace further. So simple as that, guys. Radio detection sell the yellow extension reels, guys, and if you're doing a lot of pipe tracing, they're certainly worth getting because they can help you. Now, in radio detection's instruction book, it'll tell you to put the earth at 90 degrees. Which is what I've done here, but I think we need to think about it more. I tend to not use it at 90, and I'll explain why. At 90 degrees, 50% of my signal will go that way, and 50 will go that way. For most people, we're only tracing one way at once. So in effect, what you're actually doing now is wasting half of that signal. It's going the wrong way. So if you think about doing this, if you put your earth this way, like on a 45, I might get 70 going that way. Do you get the idea? So I can kind of direct it to which way I want it to go by altering that angle of the earth. Okay. Also think about this. If you've got a house up here with a service pipe to it, and I want to trace that by connecting onto here, if I put it this way or this way, yeah, it's going to want to do that. But if I put it that way, it's going to want to run up it. I think some of you said you were on water leakage, I think, or water repairs. So you maybe got to trace, you know, metal water services. Consider a couple of things with this, guys. If you've got a house, you've got a water service coming out. If you hook up to the inside there and put the earth at the back, your signal don't want to run down that pipe. You know, think about, you know, angling your earth down to where the water main is. Yeah, your signal's trying to get to that pin. Put the pin where you're trying to trace it. Do you all understand that, guys? Just gonna have a minute and a little drink. So give me some feedback on that. See if you're all okay with it. Anything you want me to expand on? While you're answering that, guys, just want to show you the problem with sometimes extending your earth out. And again, we've got this in the street outside. So that's our pipe. And we hook up to the pipe and put the earth down here, and we get signal along here. But we've also got an electric cable going like this, and we get signal down that. Now, in reality, this should give us the strongest signal. In reality, okay? However, we have to consider depth. That pipe is 1.5 meters deep. That cable is 0.5 meters deep. From the surface with our locator, this one is now the strongest signal. For you guys using 8000s, this is where your current direction comes in and your current measurement comes in, okay? They're the benefits of high-end locators. But what we do here, guys, is if we shorten that earth pin, yeah, if we move that from there, and we actually, what we do here is there's actually a rim around the box, like a valve lid. We actually earth to that, so nice and tight in, and that decreases massively the amount of signal on this. So the takeaway from that, I guess, guys, is the earth position is important, but there's no set place to put it. Think about what you're trying to do. Think about moving it. Try it in different positions and all that kind of stuff. Okay. During this session, guys, you've heard me talking a lot about hooking up to houses to get a signal on the electric cable. I just want to show you some little tips of how we do that. We don't need to use a plug-in adapter. So around a building, there's a few things that you're looking for. You're looking for a flow boiler, light, tap, gas riser, gas meter. If you hook your Genny up to any of these things, because of the cross bonding inside the house, you'll trace the electric. Sometimes confuses people, this, guys, but here we've got a gas entry. Inside properties, gas pipes have to be metal by law. We've hooked up here, earth with some water. The signal can't travel back down the plastic. It's got to go in the house on the metal. And the metal, of course, is bonded to the electric, so it comes back on the electric. So I know it sounds backwards, but by clipping on somebody's gas entry, you will get a really good trace on the electric service and the main. So for you guys that are surveyors, if you're trying to, you know, locate the LV main down a footpath, go and find a nearby building, nearby house, get hooked up to it, get a signal on it. Make your life so much easier. Gas meters are great, guys. Got an outside gas meter, just hook up to the inlet like here. If you can't get at that, open the lid and clip on there. Outside lights, again, metal, just hook up to them. These are really good, guys, as well. Got a blow up on a boiler. Hook your Genny lead on that. You'll get a perfect trace on the electric. Works really well. There's loads of ways of tracing domestic services, guys. Loads of ways. Around properties, I've done all sorts of stuff utilising the cross bonding. Taps as well. The problem with a tap is you can sometimes get inside plastic water. Just give me a minute, guys. I'm boiling in here. I'm just going to open the window. It's suddenly gone warm. It was freezing in here this morning. It's boiling now. Okay, so all these ways of tracing that. Guy, well, I want to you Cat4 users in particular, guys. If you use Cat4, have you ever had a situation with the Cat4? It's one of the biggest complaints we get about the Cat4. This actually, have you ever had a situation, particularly on Genny mode, where the cat's been quite erratic? And what I mean by that is you've turned the sensitivity control up just a fraction, and you've got full signal, and then you try and just back it down a tiny bit, and you end up with no signal. You can't kind of get your needle in the middle. It's either all on or it's all off. Has anybody ever had that experience with a cat before? Oh, there's a nice fresh air coming through now. That's nice. So the reason for it, and it's the same with other locators as well, guys. We're talking about Cat4. Is there are a few reasons, but the main reason that typically happens is that you have too much signal on the utility. The signal's too strong, basically, and it makes the cat behave quite erratically. And this is a problem with all the kind of historical training that a lot of people have had. They talk quite a lot about make sure you get a really good earth and stick that pin right in and make sure you get a really good dropping tone. And it's not true, guys. You know, we don't want bucket loads of signal on there. We just want enough to be able to locate it. Put too much signal down it, and it causes us problems. So if you look on the video now, what I want you to see on here is watch my finger, how much it moves, and then watch the needle here, and you'll see what I mean. It's either full or it's off. I can't get it in the middle here. So let me just play this for you. There's no comments coming back in about that Cat4, so maybe you've not had it, but oops. So to correct it, we turn the power down, and the easiest way of turning the power down is by pulling that earth out. And you'll see now that it fixes it. See that, guys? Okay. If it's especially wet as well, if it's especially wet, you can sometimes just pull it out and just stick it on the floor. You guys still there? So that's how we can put a signal onto a house service. And the other good thing that we can do with this is there's a few little tricks we can do with a Cat4, which are like, you remember we talked about it being dual frequency, and when it's turned up quite high, you'll hear the two frequencies and stuff. So let me just show you what I'm doing here. I've basically got the house here, yeah, with the service coming out and then the LV main like this. So I've got 100%, I've connected onto here, by the way. I've got 100% here and then 50-50. And when you have this, you get quite a unique thing that happens on the joint. And I'm going to show you. So on the video, this works with most locators as well, guys. So on the video, I am now locating the LV main. So just to be clear, guys, if you look at my drawing, I'm here at the moment, yeah? Facing that way. I'm going to find the LV main, and once I've found it, I'm going to turn the sensitivity control up until I can hear both frequencies coming through. There's a little reference point. So you'll see now I'm going to crank that right up using the manual gain. Hear the changing tone, stop turning, walk forward. The signal will drop to 0. When I carry on walking, it will come back up. I will now reverse. And that point there where it drops to 0 is the joint. I'll turn the other way now. That is the house service. Okay, so that's a neat little trick you can do. Of course, guys, you remember with this that obviously when we're doing this training normally, we do the theory and then we go and do the practical outside. So we kind of show people the theory and science behind it, and then we go out and practice it. I can't do that with you guys. You'll have to go out and practice on your own and see if you can have a go with these techniques. You might remember mentioned before about the dual frequency coming from this transmitter. The 131 is really cool. There's some really cool little tricks we can do with it. Again, not got loads of time to go into massive amounts of detail, but with 131 we can make it jump gaps. We call it capacitance effect. So there's no kind of physical metal to metal connection here. We're using the transmitter leads to make signals jump onto something else. So on the left is on somebody's Sky cable, Sky TV. That puts a signal into the house through the Skybox back out on the LV. This one is on a BT cable coming down a pole, and this one's a BT cable into somebody's house. Loads of ways we can use capacitance techniques, guys. For you guys that are using RD8000s, you can do the same thing. You'll just need to ensure that your transmitter is set to 131. On a Genny4, remember it's kicking out on both at the same time. A bit simpler. This is a BT cable coming out of a property. Very, very hard to trace these guys. You'll certainly not get them without a Genny, but you need to consider how you apply the Genny signal. Just hold it on like that. That's all you have to do. And then some smart ass always says, what if you're on your own? So on this one, I've sellotaped it on. Bit of water for the earth, just to show you can still do it on your own with a bit of effort. And that's me tracing it out. Last little one, guys. This is me tracing out an LV service. Listen to the tone from the cat. You're hearing the high frequency coming through, the 131. And just watch how I've done this. Go back to there. And you'll see that this is actually a plastic light, guys. If you remember a metal light, I'd clip on. Plastic light, just wrap it around about 3 times. Again, if you're using an RD8000, 131. Okay, guys, I'm just going to grab some water because I'm red hot and have a little minute. So just let me know if it's all making sense so far. And if you've got any questions, just fill my water up. Oh, cool. Everyone's good. No questions. Oh, that means you're understanding it. So now we've looked at. I just want to relate this back to our method now. If you think about what we've done so far, we've hopefully been in our street and we've located all the lighting, and then we've located all the LV services, and we've also started to locate some of the LV mains. So we're concentrating on the electrics, yeah. Sorry, siren going off. What we also need to now consider is multiple LV mains. And I'm going to show you some examples. Now, I know Rebecca's here with us, so she'll probably recognize this drawing. This is some stuff up at Livingston, and it's a little example that we use. So if you're not familiar with Scottish power plants, the LV is brown and the HV is red. If you kind of imagine here, we've got 4 cables, 2 HV, 2 LV. The cat on power and radio doesn't make any sense about it. You just get a signal everywhere. Let's ignore the HV for now and let's focus on how we can find those 2 LV cables accurately. If using the techniques I've just shown you about hooking up to a building, if we hook up to house 6, the majority of the Genny signal will be on the top cable, so we can locate it. We then hook up to house number 5, the majority Genny signal will be on the bottom cable, we can locate it. So we're going to use our plans to help us, yeah? We're going to look at the plans to help us plan our attack, if you like, of where we're going to apply the Genny signal. This is a UKPN drawing for Kent. And it is, if you're not used to plans, guys, it can be confusing. Each region in the UK has different standards of plans and different colours. So whereas you just saw on that one, Scottish Power used brown as LV, down in Kent, UKPN used green. People often look at that, think it's cable TV, but it's not. So there's 2 LV mains here. The cat on its own, again, only finds 1 on both power and radio. We need to find them both. So let's zoom out, take a step back and look at these cables in more detail. What we can see, so imagine we're digging here, But what we actually see down here is the split. So where does this house get its power from? Top or bottom cable. And where does this house get its power from? Top or bottom cable. You get the idea, guys? So by applying my Genny signal here first and then here second, I'll locate those two cables really easily. I could even use the columns here, guys. But it's a principle is what I'm talking about using your plans to help you, think outside the box, forgive the pun a little bit, but we focus too much on the excavation sometimes without thinking about what might run through it and how we get a signal onto it. The other thing that I want to touch on here is depth. So a lot of the Cat4s now, there's a plus version of depth estimation on it. And I know that for some companies out there, they don't like the guys having depth. In fact, there's a training course going on next door. We had a conversation about depth before. What we have to understand, though, is that depth isn't just to see how deep something is before we excavate. It gives me a lot more information than that. So on this example here, what actually happens is, so remember the mindset again. We're digging a hole here, but I'm not going to start excavating until I've found both those cables with my locator. Okay, we hook up to this house and we trace this cable and we get an X marks the spot. Then we hook up to this house, we trace this cable, but it's actually in the exact same position. Bang on the same mark. So your first thought is kind of, am I tracing the same cable again? Is it actually split? Do you know what I mean? Is the two separate cables there? However, when I was hooked up to house number 1 at this X here, I did a depth estimate on the cat and it was 600 mil. When I'm hooked up to house number 14 over here, even though the locate is in the same place, the depth is now telling me it's 300 mil. Do you understand what that's telling me? It's telling me that I have found both those cables. The reason the mark is in the same place is because they're on top of each other. Do you all understand that, guys? Please just give me a yes if you're okay with that. So depth has its uses. Yeah. I can give you another 10 reasons why depth's important, guys, but we haven't got time on this session. There's many reasons for it, not just to see how deep something is before we dig on it. Similar one here, guys. This is Western Power. Again, blue LV. So imagine that we're excavating here. We've got 2 LV mains to find. Okay. What does a cat do on power and radio? Finds one. So how do we find them both? Because sometimes people say, well, it's all right you're saying that, Pete, but my plans don't show house services. Right? Doesn't matter, does it? Where does this house get its power from? Yeah. And where does this house get its power from? We don't need the house services on there to tell us. It's pretty obvious, isn't it? So we hook up to this house and we trace that one, and then this one, and we trace that one. So hopefully, guys, that makes sense. But what I'm trying to get at here is we need to plan the survey a little bit. We need to use our plans and look at where is the best place to put that Genny going to be. And remember what the session's called? How do we get the best out of the Genny? And this is how we do that. So we're then back to our process, guys. Sorry, we've hopefully now done all the LV. Yeah, we've located it all. Now we're going to move on to the comms, and this is where our signal clamp comes in, guys. So signal clamp, and we place that around a cable like this. So typically speaking, BT, cable TV. On this section, guys, I'm not going to get into the rights and wrongs of lifting lids. Okay, all I would say is just refer to your own company policies and procedures, etc. for that. Okay, I'm not going to open up a debate on that, guys. So, but that's what we use the clamp for. Okay. So we've located the lighting, we've done the LV, we've now located the BT, and we've done the cable TV. So can you see what we're doing now? We're building up this picture layer by layer. Okay, this is what I mean about location, not avoidance. Okay, we're hooking up to stuff and getting it marked out. We then move on to induction, which is where we just use the box. If I can get this to work. I want to be clear though with induction. Last resort. We should exhaust all connection and clamping options before we move on to induction. This is another issue, guys, with the cat data download that I'm seeing, is that because the guys know that we're going to download the cats and see how much Genny usage they're doing, they're just banging it on induction, some of them, and sticking it 10 meters down the footpath and leaving the thing bloody running for an hour just to get usage up. So we need to ensure that we're still applying these connection methods and clamp methods. There's a couple of issues with induction. Okay, it works, but there's a couple of issues you have to be aware of. Okay, number one, We've talked a lot about the benefits of this Genny4 having simultaneous dual frequency, kicking out 33 and 131 at the same time. 131 is high frequency, remember? High frequency is very good on cables that aren't earthed very well, things like comms cables, that kind of stuff, yeah? When we use induction, we don't get 131, we only get 33. So you're restricting yourself, if you like, with the Genny. You're not getting the best out of it, okay? That's the first point. The second thing you need to consider is that it's not selective. So just to rewind for anyone that doesn't know, guys, sorry, just some of the basics. Plug the leads into the Genny, it's on connection. All the signal is sent out down the leads or the clamp. When you disconnect the leads, it's on induction, and we get this kind of airborne signal, if you like, coming out from the Genny, like you can see on the slide, basically. So it's been emitted from the Genny, and then we sit that down over a buried pipe or cable, and it throws a signal onto it, okay? You need to be 10 meters away with your cat though now. If you're less than 10 meters away, you'll pick up a direct signal from the Genny, which is what we don't want. So if we look here, can you guess what I'm doing there, guys? I'm trying to locate the BT, yeah? So I'm suspecting, because, you know, this box is here, I'm suspecting there's a BT here. I'm trying to do it. I would not advise you do this unless you absolutely have to, guys, okay? Because you can quite often get it wrong. This is outside our office. Again, I'm actually up here somewhere. There's a power cable that runs down here parallel with that BT. Which do you think is the best conductor? The BT or the power cable? Importantly, which has got the better earth on it? Remember what we're doing with this Genny signal? Of course, it's the power cable, guys. So even though the Genny's sat above the BT, that signal goes for that. The problem with that is that you're 10 meters away down that footpath, tracing the power cable, but you think you're tracing the BT. I have lost count of how many sites I've been to on a site visit, and I've seen the BT and the power cable marked in the same place. And as soon as I see that now on site, alarm bells start going off, because I start thinking, how have they located that BT? And quite often you find they've induced onto it like this, and they've not actually located the BT. They've just relocated the power again, okay? So quite often with BT, guys, the only way of doing it is to lift and clamp, okay? Even with induction, we can sometimes struggle. HV cables, guys. HV are the hardest cables to detect. Again, guys, it's a short mini session. I can't go into all the reasons why like we do in a full course. Typically speaking, you guys might have experienced this. You tend to get stronger power signals off LV than you do off HV. HV is normally deeper. The biggest issue with HV is where can we connect a Genny to it? For most of us guys that can't get in subs. Yeah, Joe, absolutely. Send me cable TV as well, inshallah. So we can't connect onto it. So the only option we've got with HV a lot of the time is induction. It's the only option we've got. But the problem is this, guys. Look at this. Footpath, LV, HV, deeper, yeah? So even when the Genny's here, can you see what's going to happen? We end up lighting this thing up. So that's why it can be very tricky with HV sometimes. So what we do is this, guys. This is back to that UKPN drawing. So remember on this, guys, the green is LV, the red's HV. We're proposing to excavate here. The cat only finds the LV. No matter where I put this Genny, I only find the LV. All these examples I'm showing you guys, I've worked here and done this, okay? So the real, basically. So we can't pick it up. So what we do, like before, we zoom out. Let's have a look. What we can see over here is this separation. If I apply my Genny signal here onto the HV, I can now locate it back down here. That makes sense, guys, because the LV is not kind of blocking it, if you like, anymore. So what we try and do with HV, I know you can't always do this, is try and find a bit of separation, maybe a road crossing or something like that. Again, guys, I hope you're okay with that. Well, that makes sense. Same here, guys. Excavating here, we induce here. What I often do, guys, is do HV last. It's very tempting to think, oh, we've got HV, we'll do it first, but do it last, and the reason for that is simple. You've already got stuff marked up. So if you do accidentally induce onto another utility, you know you've done it because you're picking up the same thing again. You see what I mean? Okay. You all happy so far, guys? All making sense, I hope? Any questions? Okay, next question I want to ask you guys is, have you heard of a two-man sweep before? Two-man parallel cat and Genny sweep? Have you heard of one? I want to know if Have you been trained to do that, or have you done it? Is it something that you do? Give me some feedback on that, and we'll have a discussion about that. While you're answering that question, guys, I want to show you something. Wait, I'm going to put my full video thing up now for a minute, guys. Hello. when you're using a locator or induction, you know you've got to be 10 meters away from the transmitter. Just going to jump up for a second while I show you this. Hopefully you can still hear me. Even when you're 10 meters from the transmitter, you can still pick up a direct signal to the locator. So quite often what happens is your Genny's 10 meters away. There is actually no utility there, but the cat's still giving you a signal, or your locator's still giving you a signal. And it looks just like a cable as well. You'll move it backwards and forwards and it'll look just like a signal, but it's actually airborne. So one of the things I want to quickly show you is how you test for that. So if you imagine that I'm stood here with my locator and my Genny's 10 meters away that way, and I'm getting a signal, I'm thinking to myself, is that signal coming from an underground utility, or is it coming directly from the transmitter? And the simple way to tell is by lifting your locator and pointing it towards the transmitter. If I lift and my signal increases, it's coming from the transmitter. If I lift and my signal decreases, it's coming from underground. And that's a very simple way how you can tell where your signal's coming from. Okay, guys. So we're getting kind of towards the end of our survey now. Really. We've done all our connecting and stuff, haven't we, and clamping and things. So this is where we talk about the kind of final induction techniques. And the reason I brought up the two-man sweep is I know a lot of people have been taught to do this, and I have some concerns with it. It's a technique that's still being taught, and I think we just have to be careful. First of all, for anyone that doesn't know, let me explain what one is. Still using induction. If you imagine that I've got a footpath here and I've got my excavation here. Okay, the idea of a two-man sweep is the cat is here, if you like, and the Genny's here. So I've got somebody with the cat and somebody with the Genny. And the idea is at the same time they walk together across. So if you imagine them both walking together. And the idea is that if there's anything coming across here, they'll hit it at the same time. Okay. Hopefully that makes sense, guys. Now, the problem with this is that I wouldn't recommend doing it in a footpath or a carriageway. And let me explain why. It's not bad for road crossings, I guess, and stuff, but what we could potentially have in a footpath is a cable that does that. And that's not uncommon, guys. You know, it's changing position in the footpath. You imagine you're here with your cat and your Genny's here, and you walk across at the same time. In the starting position, the cat isn't going to detect it because the Genny's not on it. Then you walk together. But by the time the Genny's on it, the cat's not. You see that? Okay. So that's one of the potential downfalls of a two-man sweep, is that if a cable changes position between the cat and the Genny, you can miss it, you see. So the technique that I teach people to do is what's called a blind induction sweep. We're going to come to that shortly, Joe. Hang on, yeah. Have a look at the picture there, guys, or the 6 pictures. You'll see that the Genny's in a different position on each one of the 6 pictures. So what I want you to do is just kind of keep that in your head, if you like. Just memorize that picture, and then let's transfer it to the real world. If that's my footpath again now, this could be a carriageway, guys. I keep using footpaths, but it could be a carriageway, doesn't matter. That's the bit that I'm interested in. I'm going to go 10 meters away because that's how far away my Genny has to be. And I put the Genny over the curb with a handle like that, and I scan across. Then I put the Genny here and scan, then here and scan. If you think about the pictures before, yeah? Here, scan, here and scan. It effectively does exactly the same thing as a two-man sweep, but what it does do, it accounts for anything that doesn't run straight. Because as long as I scan the whole width of that on each Genny position, even if a cable runs diagonally, I'm still going to find it. Just give me some feedback on that, guys. Does that make sense? And you can see the difference between that and the two-man one. Yeah, two-man one's good for big areas, but on footpaths, carriageways, I tend to think, I call it a blind induction sweep. Some people call it a footprint sweep or something, but that's what I think is a better way in that situation. Let's just finish off then talking about our method that we talked about. Do you remember? We did, it seems like ages ago now, we did the lighting, we did the LV services, the LV mains, the comms. we've done pipes. You know, we're locating all these things one at a time, and this is kind of the last thing that we do. The final thing that does the orientation of the Genny to the direction of the service have any effect? Yes, Luke, it's got to be in line with it. So the handle of the Genny has to be in line with the utility. Roughly though, 45 degrees, you'll still be fine. Okay. Yeah. So yeah, roughly handle in line. Yeah, I think what you're getting is if it's running diagonally under the Genny, will you still get it? And yeah, you will. It's not bang on in line. The final thing we could do with the Genny, guys, is nulling out, and I think this is what somebody was referring to before about putting it on its side. There's many reasons why we null out, guys. I can't go through all of them again, but I'm going to give you one example. Do you remember we talked about the HV situation that we had before? And you remember we said we had the LV here and the HV here. Okay, possibly something else here, but that's our HV. And can you see that no matter where I put the Genny, I can't get signal on this. It's either going to be hitting that or it's going to be hitting that. Yeah. So our plans are telling us there's HV there. Okay, but we can't find it. We've tried passive modes, we've tried induction, can't find it. This could be out. Now, this is where I was talking before, guys, about, well, you might want to look at your plans now and find some separation. Do you remember we talked about that just a little while ago? But let's say you can't. So your plans are showing you that the HV and the LV are together all the way up that footpath. So what you might want to try is nulling out the LV. Look at the signal on the Genny on either side. You can see that dead zone there. If I tip the Genny on its side like this, I've now got that, haven't I? Make sense? So if I put the Genny on its side over the LV main, the one I keep finding, the one I don't want to find anymore, it's blocking everything else. It cancels that out and throws signal down, and hopefully lights up the HV for you. So that's yeah, that's why we null out and how we null out, guys. Oops. Guys, there you go. That was my session on how to get the best out of the Genny. I hope it was worthwhile. Has anyone got any questions or anything else you'd like me to expand onto? I'm not in a rush to get off at the minute, so if there's anything you want me to cover while I'm here, I will do. Give me some feedback, guys. Was it all right? Did the software look all right? Was the content okay and stuff? Let me know what you thought. I hope it was a useful use of what we've been just over an hour and stuff. So I hope it wasn't a waste of your time. Thanks, guys. Yeah, no worries, Alison. Catch you later. Thanks, Tom. Thanks, Phil. Cheers. What's Luke saying? Any advice for a fencing contractor working at 2 or 3 different small sites a week? Sourcing drawings isn't always easy. Luke, drop me an email. Probably be easier if we have a natter about that, so I can get exactly what you're going on about. Send me an email. I'll quite happily give you a ring, Luke, and have a chat with you. Thanks, Jake. Thanks for the feedback. Cheers, David. Thanks, Brian. I don't think there's any questions coming in, guys, so if it's okay with you, I'm going to go and have a little tinkle. I have got another one coming up, I think at 1. Is it 1 or half 1? Can't remember. I don't know if anybody else is in here who's on that one. It's the last one I'm doing, and we're going to be having a chat about power and radio and just some of the problems if you rely too much on passive modes. You can probably tell I'm a massive fan of the Genny. Okay, so yeah, if you're on that one at 1, I'll see you then, guys. If not, I'm going to turn my video off now, guys. Thanks again, and I'll catch you later. Brian, I'm still here. Earthing problems. Not sure what you mean. Again, Brian, just drop us an email if you wanted to just go into anything in a bit more detail. I'm going to have to shoot because I'm desperate for the toilet now, guys. So I'll catch you later.